Good morning, friends. So after the lockdown, we couldn't continue our classes. So this is the only route left for us to continue our studies. So I hope it will be helpful for you. So in the last class, in the classroom, I was teaching you double integration. I taught you triple integration, some important problems of triple integration, and then we did change the order of integration. By changing the order of integration, we solved double integrals. So now one more important topic is here in integral calculus here, beta and gamma functions. These are the improper integrals. See here, integration is quite vast compared to differentiation, and in differentiation there is a particular root is there. Suppose if two functions are in multiplication, you do by product rule. If they are in quotient, you apply quotient rule. But nothing is like that in integration. So you need a lot of practice, and some integrals are there. Any method is not at all useful there. You cannot, such integrals are called improper integrals, and they are very difficult to solve. So two integrals are there, beta improper integrals are there. One is beta, another is gamma function. Both the functions will go in detail. By using these functions, learning these functions, application of these are very important in various engineering fields. Okay, so now we start first without going into details. That is not at all needed for you at this stage. So I will start gamma function. I will start directly gamma function. First of all, gamma function is denoted like this. Suppose n is there, means gamma n means like this. This is gamma n. So this is the notation. Gamma n is denoted like this. Now how it is defined? Gamma n is equal to, it is an integral that is from 0 to infinity x raised to n minus 1 e raised to minus x dx. This is the definition of gamma function. You keep it in your mind. So gamma function, gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. So this is the definition of gamma function. Now based on this definition, certain theorems are there that you have to prove. So first of all, I will derive recurrence formula. Based on this gamma function, I will derive recurrence formula. So what is recurrence formula? What you have to derive here is, we have to derive gamma n plus 1 is equal to n gamma n. Gamma n plus 1 is equal to n gamma n. Now you see here, we know that already gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. This is equation 1. Already we defined this one. Gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. Now what I do is, I want n plus 1 here in the LHS. So here also in the question, wherever n is there, I will replace that n by n plus 1. So here you write replacing n by n plus 1. Replacing n by n plus 1. So now wherever it is n, you put n plus 1. So now this becomes gamma n plus 1 equal to 0 to infinity x raised to, again n is here, replace it by n plus 1 minus 1 e raised to minus x dx. E raised to minus x dx. What I did is, I defined gamma function, and wherever it is n, I replaced it by n plus 1, so that LHS becomes gamma n plus 1. Gamma n plus 1. So now you see here, this becomes gamma n plus 1 equal to 0 to infinity. Here this plus 1 minus 1 get cancels. What remains is x raised to n minus e raised to x dx. X raised to n e raised to minus x dx. E raised to minus x dx. Now we shall integrate this by parts. So integration by parts. First function as it is, integration of second function minus integral sign, differentiation of first function into integration of second function. That rule we shall apply here. So now this becomes 0 to infinity. So we shall apply an integral. So you take this as first function, this as second function, first function as it is, integration of e raised to minus x is minus e raised to minus x. Limits are 0 to infinity. First function as it is, integration of second function minus integral sign, differentiation of first function nx raised to n minus 1. Again integration of second function is e raised to minus x dx. This is the first function, this is second function. You keep first function as it is, integration of second function minus integral sign, differentiation of first function into integration of second function. You might be wondering how it comes. Integration of e raised to minus x, e raised to minus x by minus 1, which becomes eventually minus e raised to minus x. So now what we do now, here we will substitute first upper limit wherever it is x minus lower limit. When you substitute upper limit, remember e raised to infinity is 0. Just keep it in your mind. E raised to infinity is 0 and e raised to 0 is 1. E raised to infinity is 0 and e raised to 0 is 1. So now when you substitute infinity here, e raised to infinity it becomes e raised to infinity is 0 minus, when you substitute 0 here, x raised, here value of x is 0. So this entire thing will now becomes 0. Entire thing now will becomes 0. So now here this is minus minus becomes plus, n constant you take outside, 0 to infinity x raised to n minus 1 e raised to minus x dx. X raised to minus 1 e raised to minus x dx. So LHS is gamma n plus 1, this equal to n as it is. You see here, this much is the definition of gamma function. This is the definition of gamma function. So now this becomes gamma n. Therefore, gamma n plus 1 is equal to n gamma n. This is equal to n gamma n. This is the recurrence formula and mostly used in the problems. So two things you remember now. First of all, gamma n is defined by 0 to infinity x raised to n minus 1 e raised to minus x dx, and second formula is gamma n plus 1 is equal to n gamma n. Gamma n plus 1 is equal to n gamma n. Now we shall move for third derivation. So third derivation you have to prove is gamma n plus 1 is equal to n factorial. You have to prove gamma n plus 1 is equal to n factorial. Just to be proved that gamma n plus 1 is equal to n gamma n, isn't it? Gamma n plus 1 is equal to n gamma n. Here, n as it is I will do. What I do inside the gamma function here is I will add 1, subtract 1. So now this becomes like this, n minus 1 plus. Does it make any difference? No. I have added 1 and I have subtracted 1. So now this becomes n minus 1 plus 1. Now tell me, just I told you, gamma n plus 1 is equal to n gamma 1. So similarly, gamma n plus 1, n minus 1 plus 1 is equal to n minus 1 gamma n minus 1. Are you following this one? This is very important here. So now gamma n plus 1, just to prove that n gamma n. So n minus 1 plus is equal to n minus 1 gamma n minus 1. So same I will apply here. So now this becomes n minus 1 gamma n minus 1. Once again, if I add and subtract here 1 and minus 1, it becomes n minus 2 plus 1. Again, which is can be written as n minus 2 gamma n minus 2. So this will continue. So now this can be written as n into n minus 1 n minus 2 gamma n minus 2. Again, this can be written as n into n minus 1 n minus 2 n minus 3 gamma n minus 3. So n into n minus 1 n minus 2 again n minus 3 n minus 4 gamma n minus 4. So this process is continued. This process is continued till what you get? n minus 1 n minus 2 continue like this up to 1 gamma 1. n minus 1 n minus 2, then when the whole integer is there means n minus 1 ek kami karat जा, last value will get 1. So n minus 1 n minus 2 up to 1 into gamma 1 into gamma 1. Now you see here 4 factorial means what? 4 factorial means 4 into 3 into 2 into 1, isn't it? 4 factorial means 4 into 3 into 2 into 1. 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. In the similar way, here you see n minus 1, n minus 2, n minus 3, up to 1 it is coming. Means starting value n2 up to 1 last. So this can be written as n factorial. So 4 factorial has become 4, 3, 2, 1. n minus 1 n minus 2 एक कमी होत 1 पर्यंत उरलाय, means this can be written as n factorial into gamma 1. So here left hand side is gamma n plus 1. Gamma n plus 1 is equal to n factorial into gamma 1. Now the question is what is the value of gamma 1? What is the value of gamma 1? Now we shall find that one. Now just to define, gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. In the similar way, gamma 1 is equal to put n आहे तो 1 ठेवा. So 0 to infinity x raised to 1 minus 1 e raised to minus x dx, or gamma 1 is equal to 0 to infinity x raised to 0 e raised to minus x dx. X raised to 0 is 1. So now this becomes 0 to infinity e raised to minus x dx. So integration of this one is minus e raised to minus x, 0 to infinity, minus you take outside, upper limit infinity is 0, minus lower limit e raised to 0 is 1. Already this I told you, minus 1. So what I calculated here is gamma 1 is equal to 1. Gamma 1 is equal to 1. Now you substitute here. So now this becomes gamma n plus 1 is equal to n factorial into 1. Therefore, gamma n plus 1 is equal to n factorial. Gamma n plus 1 is equal to n factorial. Got it? So 3 things you have to remember till now, whatever I taught you. First of all, you should know the definition of gamma function, that is 0 to infinity x raised to n minus 1 e raised to minus x dx, and second is gamma n plus 1 is equal to n gamma n, and third is gamma n plus 1 is equal to n factorial. Gamma n plus 1 is equal to n factorial. Now based on this one, just to see here, okay, तो आतापर्यंत काय शिकलो तुम्ही? फर्स्ट ऑफ ऑल गामा n gamma n is equal to 0 to infinity x raised to n minus 1 e raised to minus x dx. Second thing is gamma n plus 1 is equal to n gamma n, and third one is gamma n plus 1 is equal to n factorial. Gamma n plus 1 is equal to n factorial. These three formulae you remember from me. So now based on this one, just I can say now, if gamma n plus 1 is equal to n factorial means, suppose if I ask you what is the value of gamma 2, gamma 2 can be written as gamma 1 plus 1 means n plus 1, n is 1 here. So this is how much? 1 factorial. So the value of gamma 2 is 1. Similarly, gamma 3 is equal to 2 plus 1 means 2 factorial. Gamma 3 is 2 factorial means 2 into 1 equal to 2. Similarly, gamma 4 can be written as gamma 3 factorial. This is 3 into 2 into 1 equal to 6. And gamma 5 is equal to 4 factorial. 4 into 3 into 2 into 1 equal to 24. Equal to 24. So you remember gamma n plus 1 is equal to n factorial, means gamma 2 is 1 factorial, gamma 3 is 2 factorial, gamma 4 is 3 factorial, gamma 5 is 4 factorial, and so on and so on. Got it? The things are clear now? So first is you should know what is the definition of gamma function. Second is gamma n plus 1 is equal to n gamma n, and third is gamma n plus 1 is equal to n factorial. N factorial. Now we shall solve some small problems here. Now evaluate gamma 7 by gamma 5. Gamma 7 by gamma 5. Gamma 7 is 6 factorial. Gamma 5 is 4 factorial. Gamma 7 is 6 factorial. Gamma 5 is 4 factorial. So 6 factorial can be written as 6 into 5 into 4 factorial. You stop here because 4, 3, 2 and instead of adding that one, because already in the denominator 4 factorial is also there. So this get cancels. This is 30. Answer is 60. Otherwise you can do in detail also. That is 6 into 5 into 4 into 3 into 2 into 1 divided by 4 factorial is 4 into 2 into 2 into 1. So this and this get cancelled. Answer is 30. Why doing all these things in detail? Once it comes to 4 factorial, we should stop here because already there is 4 factorial in the denominator. That 4 factorial and this 4 factorial are going to get cancelled. So now this is 6 into 5, 30. 6 into 5, 30. Next problem. Gamma 5 by 2 divided by gamma 3 by 2. Gamma 5 by 2 divided by gamma 3 by 2. So now this 5 by 2 can be written as, if you remember, 3 by 2 plus 1 divided by gamma 3 by 2, isn't it? 5 by 2 can be written as 3 by 2 plus 1, and again this is gamma n plus 1. Gamma n plus 1 is n gamma n divided by gamma 3 by 2. So now this gamma 3 by 2 get cancels. This is 3 by 2. Answer is 3 by 2. Gamma 8 by 3 divided by gamma 2 by 3. Gamma 8 by 3 divided by gamma 2 by 3. Now this 8 by 3 can be written as 5 by 3 plus 1 divided by gamma 2 by 3. So this can be written as now 5 by 3 gamma 5 by 3 using the formula gamma n plus 1 is equal to n gamma n. This is gamma 2 by 3 or this is 5 by 3. Again gamma 5 by 3 can be written as gamma 2 by 3 plus 1 divided by gamma 2 by 3 or this equal to 5 by 3 gamma 2 by 3 plus 1 is 2 by 3 gamma 2 by 3 divided by gamma 2 by 3. This and this get cancelled. So answer is 5 2s are 10 divided by 9. Answer is 10 by 9. Answer is 10 by 9. Clear the things? Now we shall move for one more important formula or derivation. You can say that this is also very important. Prove that gamma half equal to root pi. Remember, gamma half is equal to always it is root pi. So you have to prove that gamma half is equal to root pi. See, before this, actually I didn't teach you, that is polar coordinates. Using polar coordinates we find the double integration. There we come across a formula. That formula I will take directly here. So from the knowledge of double integrals we know that, remember this formula, that is 0 to infinity e raised to minus x square dx equal to root pi by 2. Just to remember this formula. So from the double integrals we know that 0 to infinity e raised to minus x square dx equal to root pi by 2. Root pi by 2. Now what I will do now, you see here, I will solve this integral. To solve this integral, what I will do now, here x square is there, put x square is equal to t. Put x square is equal to t. Now you differentiate this one, this becomes 2x dx equal to dt. Or dx is equal to dt by 2x, or dx is equal to dt by 2. X square is t, therefore x is equal to definitely root t. So here you write root t, or dx is equal to dt by 2 root t. Dt by 2 root t. Now you see here, we have changed from x to t functions. So x square is equal to t. So here these are the limits of x. Convert them into limits of t also. When x equal to 0, t is 0. When x equal to infinity, t is 0. Means there is no change in limits. So now the given question, given formula becomes 0 to infinity. E raised to minus x square means e raised to minus t. E raised to minus x square means e raised to minus t, and this is dx is equal to dt by 2 root t. Dt by 2 root t. Or this equal to 1 by 2, 0 to infinity. 1 by 2 I have taken care of root t. Root t means t raised to 1 by 2. T raised to 1 by 2. But when it comes to the numerator, this becomes t raised to minus 1 by 2, e raised to minus t dt. E raised to minus 1 by 2 dt. Or 1 by 2, 0 to infinity. This can be written as t raised to half minus 1, e raised to minus t dt. Or this also can be written as 1 by 2. Converting all t's into x, we can do like this. So this is x raised to half minus 1, e raised to minus x dx. So now this is in the form of 0 to infinity x raised to n minus 1, e raised to minus x dx. If it is 0 to infinity x raised to n minus 1 e raised to minus 6 dx, what we will write? This is the definition of gamma function. This is the definition of gamma function. That's why we write there gamma n. So here it is x raised to n minus 1 e raised to minus 6 dx, means in place of n half is there. So this can be written as half into gamma half. This can be written as half into gamma half. So now this is LHS. This is LHS. Just write it down. So now this much is gamma half, half gamma half, and this is equal to, already we know that root pi by 2. This 2 root 2 get cancels. So gamma half is equal to root pi. This is also very important formula. Remember, gamma half is equal to root pi. Gamma half is equal to root pi. So now we shall find gamma functions of some negative values. Gamma functions for negative values. So just we derive gamma n plus 1 is equal to n gamma n. So from this we can write gamma n is equal to gamma n plus 1 by n. Gamma n plus n by n. So these are useful for finding negative values. Say here, gamma minus 1 by 2. I want to find the value of gamma minus 1 by 2. So use this formula. So from this we can write now gamma n is equal to gamma n plus 1 by n. N is minus 1 by 2 here. So this can be written as minus 1 by 2 plus 1 divided by minus 1 by 2. So gamma minus 1 by 2 is equal to minus 1 by 2 plus 1 is plus 1 by 2 divided by minus 1 by 2, or minus gamma 1 by 2 is equal to gamma half is root pi by minus 1 by 2. This is minus 2 root pi, or gamma minus 1 by 2 is equal to minus 2 root pi. Gamma minus 1 by 2 is equal to minus 2 root pi. Just go through it. Now, suppose I want to calculate the value of minus 3 by 2. Gamma minus 3 by 2. Same formula use now. Gamma n is equal to gamma n plus 1 by n. So this is minus 3 by 2 plus 1 divided by minus 3 by 2. So gamma minus 3 by 2 is equal to minus 3 by 2 plus 1 is gamma minus 3 by 2 plus 1. So minus 3 by 2 plus 1 divided by minus 3 by 2, and this is minus 1 by 2 divided by minus 3 by 2, or minus 3 by 2, but gamma minus half just we found out, it is minus 2 root pi by minus 3 by 2, minus minus get cancels, 2 goes to the numerator, this is 4 root pi by 3. Gamma minus 3 by 2 is equal to 4 4 root pi by 3. 4 root pi by 3. Now, gamma minus pi by 2. Gamma minus pi by 2 can be written as gamma minus pi by 2 plus 1 divided by minus pi by 2, or gamma minus 3 by 2 divided by minus pi by 2, or this is equal to gamma minus 3 by 2 is, just to be calculated, it is 4 by 3 root pi divided by minus pi by 2, or this becomes, 2 goes to the numerator, 4 2 minus 5 into 3 into root pi, or this is equal to minus 8 by 15 root pi. Minus 8 by 15 root pi. Okay, got it? So once again, I will rewind the things whatever I taught you today. First of all, I started beta and gamma functions. There I defined gamma functions. Gamma is denoted by like this, gamma n, and it is defined as 0 to infinity x raised to n minus 1 e raised to minus x dx. So this is the definition of gamma function. This we did. Apart from this, second recurrence formula we derived. Gamma n plus 1 is equal to n gamma n. Second formula we derived is gamma n plus 1 is equal to n gamma n. Then third is gamma n plus 1 is also equal to n factorial. Gamma n plus 1 is equal to n factorial. For example, 6 gamma is equal to 5 factorial. Gamma 8 is equal to 7 factorial. Gamma 100 is equal to 99 factorial. Okay, so gamma 1000 is equal to 999 factorial. So same thing, gamma n plus 1 is equal to n factorial. This also we did. And one more important formula we did. Gamma half equal to root pi. Gamma half is equal to root pi. Okay, so this much is enough I think today. So please go through this one. Your suggestions are needed for my second video. So what is the time limit? How much time limit you need? What is the quantity, quality, whatever the suggestions are needed, I will improvise. Okay. So from the next video onwards, after teaching something, I will give you 10 problems also to solve, because now enough time is there. You cannot take excuses. We are having class, we are having assignment. You don't have anything now. So you whatever the homeworks I will give, you do it simultaneously with every video. Okay. Thank you once again.